Good morning, everyone. We're going to talk briefly about simplifying expressions. So the last couple of days, we've been talking about how to evaluate an expression given a value. But sometimes that gets really painful if there's a whole bunch of variables, and there are ways to kind of simplify what it is we're doing. But before we do that, let's talk about a couple of vocab terms. The first one is like terms. So basically, the basic definition we're going to work with right now is these are terms with the same variable. So to give you an example, 5x and 7x would be like terms. If I did 2 and 10, these are like terms. So notice how these two both have x's. Neither of these have x's. So basically, if I gave you a non-example, five x and 2 are not like terms because this one has an x and this one doesn't. Now, this matters when we're trying to simplify. Which is really what's known as combining like terms. So we can combine like terms to make an expression simpler. And I'll show you what I mean by that. So down here, this would be an example that I could simplify. Because if you notice, there's an x here, there's an x here, there's a number, and there's a number. So in this case, I'm going to rearrange things just to make it a little bit easier to read. So notice how there's a 7x and a minus 2x. I'm going to move those. So notice how the minus came with the 2x. Notice how there's a plus 9 and a plus 11. So the plus stays with the 9 and the plus stays with the 11. So all I did was rearrange terms. And so now I can see that there's a 7x minus a 2x. Well, all that really means is that I actually have a 5x. And since this is a plus 9 and a plus 11, I really have a plus 20. These are not like terms, so therefore I can't combine them to simplify. Therefore, boom, that's my simplified expression. That's all there is to it. For one like example 2, notice how there's this 5 outside of parentheses with these two things in it. Well, order of operations says I should deal with what's inside parentheses first, but notice how one's a 3x and one's just a 2. They're not like terms, so I can't add them. Therefore, there's nothing I can do inside the parentheses. So now I got to look at my next step. Well, the next possible operation is multiplication, because remember that 5 outside parentheses really means I'm multiplying it by what's inside. And what you should remember is that this tells me to use the distributive property. It tells me to multiply. It's basically saying I have 5 3x's and I have 5 plus 2's. So 5 times 3x, that really means I have 15x's total. 5 times a positive 2 really means I have plus 10 total. Once again, this has an x, this doesn't. They're not like terms. I can't combine them to simplify. So this is my final expression. All right, and then kind of one more example brings it all together. So sometimes we have a whole bunch of things going on. But once again, our order of operations applies. Therefore, the first thing I want to look at is, can I do anything inside the parentheses? Once again, they're not like terms. There's nothing I can do inside. And so now I have to think about what's the next possible operation. Well, I know there's some multiplication happening here. So let's deal with that first. And I'm just going to write that out as a step again for those of you who find that helpful. And so this is saying I have two 8x's and two plus 7s. So in other words, I have a 16x plus 14 plus 5x minus 10. All right. Well, unlike the last example, now I still have multiple terms that can be combined. So notice I have two terms with an x. I have two terms with no x. So once again, I'm going to rearrange a little bit. I see 16x and I see a plus 5x. And I see this plus 14 and this minus 10. So now I've got things together. So if I have a 16x plus a 5x, really that tells me I have a 21x. If I have a positive 14 minus 10, then I'm still going to have plus 4 left over. Once again, there are no like terms left, and so that's my simplified expression. All right. So those are three common examples that you're going to see. The last thing I want to bring up is there's something known as identifying equivalent expressions. Sounds fancy, but all it means is two expressions that simplify to the same expression. And to illustrate what I mean, if we take a look at this example right here, I'm first going to simplify this one. So I see I have two like terms in here, the 6x plus the 12x. So just like before, I'm just going to put those in an order that makes more sense to me. And so 6x plus 12x plus 22. I know I can combine the 6x and 12x. The 22, that had no like terms, and so that one simplifies to just 18x plus 22. Here's my second expression. So I know that this 2 outside tells me to multiply, and inside my parentheses are two unlike terms, so I can't combine them. So I'm just reminding myself that that actually means to multiply. So 2 times 9x and 2 times plus 11. That's going to give me 18x plus 22. All right, so notice how in both cases, they simplify to 18x plus 22. That's why I'm saying that these two original expressions are equivalent expressions. It's because they both, when simplified, result in the same exact final expression. So as always, reach out if you have questions. You're going to notice in the assignment there's some simplifying, but there's a lot more kind of explaining things because I care as much about the conceptual understanding as I do about the skill of simplifying. So once again, reach out. I'll be doing some feedback on yesterday's assignment and today's assignment over the weekend. So you'll definitely get some feedback from me very soon. Until then, good luck.